Friends, good morning. After a 1 week gap, I again come in front of you. Actually, it takes 1 month. Already I told in the last previous video, it takes 1 month after completion of Ramesh sir classes. I will come back just like. But within a small period, short period, I come to in front of you. Why? Because like this, by giving so much of gap, by giving these videos, it takes so much of time. That is a very long time. Even up to the December or January next year, not be completed. It is a practical problem. This session is given by the management, and we have to follow it. In every alternate days, the maths, bio, again physics, chemistry. Physics and chemistry one day, same Monday. Bio and maths the Tuesday. Again Thursday the maths, bio will come. Like that, if I am going to upload this videos, taking this video classes, for my turn, it takes only one period in 1 week. The next week, Ramesh sir, and the next week myself. Like that, it is going on. It is very ridiculous. Like this, we not possible to complete. Why? Because the remaining 10 chapters are there. For me, 5 chapters, and for Ramesh sir, 5 chapters. By going like this, it's very difficult. It takes so much of time. Not possible to complete. Some problem is there, you know it. The lockdown and this COVID problem is there. When we will open the college and by taking the live classes, not possible. If it is there, it is a grace of God. Okay, it is well. But up to that one, we have to go like this. And here one more problem is, we have to complete the one video class only within the 25 minutes. Some students are asking. If the class is 1 hour, like that we can. Within 10 videos, we can complete one chapter. Like that, 2 or 3 months, within the 2 or 3 months, we will complete the total syllabus. But 25 minutes, 22 minutes, 26 minutes, not possible. It takes so much of time. Okay, leave it out. For that purpose, by the session given by the management, I am coming in front of you. We successfully completed the chapter matrices. Okay now. Nearly 4 exercises, we completed all problems, examples, theory, part, properties, everything is over. Now, this is the 4th chapter. The determinants. Determinants is totally a chapter based on the matrix. Here, determinant. This is the first part. The determinant itself is a very first terminology. The term is a very good concept. That is why the chapter is named on that definition, on that concept determinant. Right, okay. But it's a determinant. So much of concept is there. Slowly you can understand what is the necessary to have that determinant, to find the determinant of a matrix. Everything slowly it will come for your mind. But all this sudden at a time it is not possible to input in our mind. Simply you take it. Some concepts in the mathematics simply you have to follow. Okay, na? Previously so many things we discussed in the first year. Listen, determinant. Determinant of a given matrix. It is given square matrix. Determinant means must be square matrix. So many types are there. You know it. Rectangle matrix is there, square matrix is there. For square matrix, only the determinant is consistent. So determinant of a given square matrix is simply a number. Here it is a number. It is a number. It is simply a number. That number may be real or complex. You know it, complex number. Real or complex. The determinant of a given square matrix is a number. It is simply a number which associates with the elements of the given matrix. For which matrix we are going to find the determinant, that is simply a number. How can we get that number? That is simply associated with the elements of that matrix. Matrix means elements. Elements means numbers. With that numbers, with that elements, we can form the determinant. Okay, very simply we take. Definition is that one. Okay. What is define the determinant means? You write this one. This determinant, it is extra. This concept will be later, it will be understood by you. That determinant, this determinant here, it is extra in the second para. This determinant of given matrix, it decides, this is very important, it concept. It decides the uniqueness of solution of given system of equations. Later, not now. It is not, if we discuss about that one, it is some clumsy, you can confuse yourself. So it is not needed, very simple. Even our textbooks, very well, it will not be given. Slowly I can tell. While we are solving the problems, I can explain that one. So this is the first para. In the first para, what is determinant means? It is related with the elements of matrix. So clearly, determinant of a given square matrix is a number, real or complex, which associates with the elements of a given matrix. Here, the second para. This determinant of a given matrix decides the uniqueness of solution of a given system of equations. Okay, it will lead out. Next, we will come to the one example. Consider capital A is a square matrix of any order. First order, 1 by 1, second order, 2 by 2, third order. In our syllabus, only up to third order. A is a square matrix, then the determinant of A can be denoted. Notation is there. This is with the vertical bars. Det A or det of A. Both are same. Det A with the modulus you write it. But don't spell mod A. It is det A. It is also like this. Det A. Consider if A is equal to 1 by 1 matrix, only one element is there. One row, one column. One element is there in the matrix. Then that A is the notation is with the vertical bars. That A is equal to that element here. Suppose capital A is equal to 7. A single element is there. Then its determinant is 7 itself. Suppose A is equal to some minus 10. Then the determinant is minus 10. It is not modulus. Notation is like that. Mod of minus A is not plus A. It is simply minus 10. This is notation, not modulus. That A, you write this one. Okay. If the matrix A is 2 by 2, A, B, C, D, 5, 6, 7, 8, some alpha, beta, gamma, delta, whatever it may be, 2 rows, 2 columns, 2 by 2 matrix of order 2. Then that A, the determinant of that given matrix A, now you see that the vertical bars, it is the notation, vertical bars, A, B, C, the same elements. What are the elements in the position, rows and columns? The same can be written, and we write vertical bars, not curved bars. Curved bars means it is a square. Without a curve, is vertical bars are there, it is a determinant. Then the determinant is AD minus BC. Very simple. AD minus BC. AD is the elements in the first diagonal. B and C are the elements in the second diagonal. You see, AD minus BC. Here AD minus BC is a number. Suppose numbers are there, we get this is the difference of product. Difference minus is there, difference. and product of elements in the first diagonal and the second diagonal. Okay, na? Is a number. You see, here clearly given. The determinant of 2 by 2 matrix is the, observing, is the difference of product of elements of first and second diagonals. These are the diagonal. We know diagonal. This is first diagonal, this is the second diagonal. Now, it is very clear. All these things we have to by heart into the definition. Even it is not necessary. If you write this one, it is good. Or otherwise you simply leave it out. What is determinant means? It is a number. That number is related with the elements of matrix. Clearly, AD minus BC is a number. That is the difference of product of elements of first and second diagonals. Okay. Now, with one example, very clearly it can be clarified. Capital S 3, 4, 6, 9, 2 by 2 matrix. Then, what is that here? That here is a notation. It is also that here. You pronounce it as a that here, not one here. It is a vertical bars. Here, vertical bars are there. It is vertical bars. The same elements 3, 4, 6, 9. It is 3 into 9 is 27 minus 6 into 4 is 24. 27 minus 24 is 3. Okay, now that is the determinant of a given matrix. Suppose to take this one. It is a matrix 2 by 2 matrix x, y, alpha, beta. Then what is that here? The that here is with the notation, the same elements with the vertical bars. Here x beta minus alpha y. Okay, now it is also a number. This is a number. Alpha beta minus, x beta minus alpha y. Suppose C is the third example. X plus y is one element. A minus b is another element. Okay. The third. Capital C is equal to x plus y, a minus b, not product to the x plus y is one element, a minus b other element. First row, second row, a plus b, a separate one, x minus 1. This is also 2 by 2 matrix. Then what is the determinant of C? That C is with vertical bars, we have to write it. Okay, na? Next, this is the product of elements in the first diagonal, x plus y of x minus y minus a plus b of a minus b. That is x square minus y square, we know it well. Minus a square minus b square. Okay, na? Like this, I have to solve. Okay? Yeah. Already we discussed the determinant of 2 by 2 matrix. It is our determinant of 2 by 2 matrix. We know it. AD minus BC is a number related with the element of the matrix. Okay. Now we are going to find the determinant of 3 by 3 matrix. Okay, now it is somewhat different and difficult one. In order to find, before that one, to find the determinant of 3 by 3 matrix, we need to know about the minor and cofactor. Minor is one terminology in the mathematics. Here this minor is the definition. The minor of element, it is always related with the element, a particular element. The minor of an element Aij of 3 by 3 square matrix of order 3 by 3 is the determinant of a submatrix which is obtained after deleting the ith row and jth column. Okay, na? Ith row and jth column. Okay. And is denoted by capital Mij. The minor with the minor of Aij. Aij we know it. Small a, ij means is an element in the capital A matrix. For that particular element, minor is always related with a particular element. Previously, determinant of 2 by 2 matrix is also associated with the elements of matrix. That is a different one. You leave it out. AD minus BC. Difference of product of first and second diagonals. That is a different one. Don't confuse. Here, minor. It is a new terminology. Minor is related with the element a single element of a square matrix of order 3 by 3 is, what is that one means? It is actually the determinant of, already we discussed, the determinant of 2 by 2 matrix. Submatrix means a small matrix in the given capital matrix. Submatrix that can be obtained by deleting the ith row and jth column. For example, A is a 3 by 3 matrix. This is a 3 by 3 matrix. A11, A12, A13, you know it well. A21, 22, 23, 31, 33, 32, 33. Okay now? 1, 2, 1, 3 means first row, first column. First row, second column. First row, third column. A21, 2, 3, 2, 3, 2, 2, 2, 1. These are second row, third row. Know it well. It is a general matrix of order 3 by 3. Then the minor of A11, determinant. For this A11, the minor is, first of all, notation is capital M11. Here also, Mij is there. Here 11 is there. So M11. This can be the determinant of a submatrix. So this is the submatrix. Okay now, after deleting that row and ith row and jth column, that means the first row and first column, where that particular element for which we are going to find the minor, you delete that row and that column. Okay now we get these 4 elements which are in a 2 by 2. That is a submatrix. Okay now, for that one, the determinant notation is there. So determinant we know it, product of elements of first two and second diagonals. A22, A33 is there. A22, A33 minus A32, A23. Okay na? That is the thing. Similarly, for example, the minor of 2, 3, for example, 2, 3, here is there, 2, 3, here is there, 2, 3. Okay na? Now, for the element 2, 3, it is capital M 2, 3, that is the notation. You delete the row where the 2, 3 element is existed, and you delete the column also. So, deleting the row and column. Okay na? Then remain the 4 elements. A11, A12, A31, A32. Okay now? Again, the determinant is same as the product of these elements and product of these elements. Minus A11, A32. Minus is there. Minus A31, A32. This is A31, it is A32. Okay na? Like that, we have to calculate. Clearly, very clearly, we are taking the numbers. Suppose the given matrix is 3 by 3 order 102, 563, 497, 3 by 3. The minor of 1, first element. The minor of 1 means you delete the row and column where that particular element for which we are going to find the minor. You delete that one. 102, 154 delete. So the remainder 16397. For that one, the minor is, the determinant is 6742 minus 93 is 27. We get that. Okay, 15. In the same matrix, minor of 6 is there. Minor of 6 now. Minor of 6. This is 6 row and column you delete. So then we get 1247. 1247. 7 1 is 7 minus 4 2 is 8 is minus 1. Okay na? Yeah. Next. The minor of 9. We delete the row where 9 lies, the column where 9 lies. After deleting that, we get 1 to 5, 3. 1 to 5, 3. Then the determinant is 1 into 3 minus 5 into 10. So 3 minus 10 is minus 7. Okay, now like this we have to calculate. I think it is clear. Okay, now 1 or 2 times you repeat it. Otherwise, not possible. Okay, now very simple. Minor, that is definition. In the theory exams, simply they ask in the question, 2-mark question, define minor. You have to write the steps. Okay, now with this example or this example also. It is clear. Okay, now? Yeah.